So what is a logarithm? A logarithm is just another way of writing exponents. You will notice you'll have this key in your calculator, so I'm going to show you how to use that key later. But this is log, your b is your base, a equals x. So in exponential form, it's b to the x equals a. Your logarithm equals an exponent. That's what you're trying to find. And so in the past teaching these, I gave another way because where these actually stand for something. So if you want to write this at the top, you can. When you have BAE, if you notice it's in this ordered bay, which you guys use that term before, after I developed this, before anyone else, I believe is what it stands for. But here's bay. This is your base, there's your answer, and your exponent. So if you were to rewrite an exponential form, it would be here's your base, there's your exponent equals your answer. Okay, so what you're going to try to do today is rewrite it from logarithm to exponential form, from exponential to logarithmic form. Okay, so you can either use this one equals x, or you could replace the x with the e to kind of help you memorize this part here. Okay, so when we're looking here, and let's say I decide to use the bay, we know it's BA equals E. So we want the base to the exponent equals answer. So 3 is our base, our exponent is this 2, and this 9 is our answer. And so that's how you write this logarithm into exponential form. So here we have 6 to the third equals 216. So the next one here, our base is 7 to the 0 equals and 1. So that's our base, that's our exponent, that's our answer. I'm going to go down to number 5, and just because you have fractions, you're not evaluating anything, you're just rewriting it. So our base is 4. Which number represents our exponent? The negative 2. Remember, it equals our exponent. So 4 to the negative 2 equals 1 over 16. Now you do number 4 and 6 on your own. Okay, go ahead and check your answer. Make sure it's correct. Any questions? Okay, so now the second part, let's take it from exponential form to logarithmic form. Remember, it's our base, exponent equals answer, and we want to write it as log base, answer equals exponent. So our base is 14. So we need to make sure the 14 looks a little bit smaller, like a subscript, okay? Our A, our answer here is 196, and it equals our E, our exponent, is 2. Now let's look at the next one. Which number is our base, the 3, the 4, or the 81? Class? 3. Which number goes next, the 4 or the 81? 81, and it equals our exponent. Okay. Number 9, our base is 12, our answer is 12, and it equals our exponent. The next one, our base is 36, our answer is 6, and it equals our exponent. The number 11, our base is 2, our answer is 1/8, and it equals our exponent. And then go ahead and try the last one on your own. And then check to make sure you did it correctly. Any questions? Okay. All right, let's turn it over to the back page, and now we're going to evaluate some logs. Now, a common log, what that is when you have a logarithm with base 10, it's called a common logarithm and can be written without the base. So if you have log base 10x, you can just write it as log x. So if you see something that has log 1000, this base is 10. So if you do not see a base, it's automatically 10. It's just like when you see an x, you know the coefficient is 1. When you see a radical with no number, we know it's 2. So when you see a log like 7 and there's no base, the base is 10. Okay, that's what a common log is. So now we're going to evaluate these. I want to show you how to do it mentally. So we're going to write this in exponential form. So let's go ahead and put equals x. And so remember, when we write in exponential form, it's the base answer equals exponent, and then you write it as base to the exponent equals the answer. So base to the exponent equals your answer. So this is going to be 7 to the x equals 49. Now you should be able to do mental math. What number will x equal to make this statement true? 2. So it equals 2. Let's look at the next one here. Let's put equals x. And we'll do base to the exponent, 3 to the x equals 27. So how many 3's give you 27? 3. So it equals 3. So now look at log 100. What's our base there? 10. So we have 10 to the x equals 100. So x will equal what? 2. Number 16, you would do 12 to the x equals 1. What would x have to equal to make this statement true? 0. Good. Okay. And we'll stop there. Except for number 19. Let's go to number 19. 19 would be 9 to the x equals 1 over 81. Well, first of all, if we want to make it a fraction, what kind of exponent do we need? A negative, and how many 9's give us 81? So x would equal negative 2. So sometimes you can just put this equals negative 2, you can replace with x and put x equals negative 2. Now sometimes it's going to come out to be a decimal, okay? Like let's say I have 4 to the x equals 10. Well, I can't do mental math on that. I know 4 squared is 16, 4 to the first is 4, so I know it's going to be 1 point something, okay? So how do we figure that out? Well, there's something called change of base formula. This is how you put it in your calculator. So if you have log base BA, you put log A divided by log B. Okay, so now if you take your calculator, you should notice that you have a log key. If you need to borrow one, if you could quietly go grab one. So on number 21, we would put log of 64 over log 16. Make sure that when you put it in the top, it'll have parentheses, close it, and then close it on the bottom. And you should get 1.5. If you do not get 1.5, raise your hand and let me know so I can help you figure out how to put it on there in the calculator. So if you find your log key, that's how you should put it in there. Now, we usually want it as a fraction. So if you have a graphing calculator, if you have math, enter, and enter again, you'll see that you get 3/2. If you're using a calculator, the yellow one, there should be an FD key. Now, if it is a decimal, then you would just round it to the nearest thousands place. Okay, so here's the next one, log 8, base A, 32. So you will put log 32 over log 8. So go ahead and put that in your calculator. And you should get 1.6 repeating. Now, when a number repeats, it can be written as a fraction. So if you hit math, enter, enter, you won't get 5/3. The thing is, if you round it, it's not going to give you an exact value. And then let's go ahead and do one more together. So log 54 divided by log 2. Now this one cannot be written as a fraction. So we are just going to round it to the nearest thousands. So that's 3 places over. So it'll be 5.755. So approximately 5.755. So let me show you how to check this. So it's like saying 2 to the what power gives you 54. And we got 5.755. So let's put 2 to the 5.755 and you get 54.00. So you see how it gives you close to it? There's no exact one number that will give you 54, but this will help us get close to it. Okay?